Okay, I'm Brady Han. I'm a commercial application specialist from LGC Biosearch Technologies. My job in LGC is to support and deploy application-based solutions. So like oligo assay-based designs, enzymes, and master mix for pre and post sales. I also provide instrumentation support through installation as well as throughout the instrument life cycles. So nice to meet you all. Thank you for attending this webinar. So the main focus for today, we'll be talking about minor groove binding probes, or MGBs for short, as they have been proven to be a powerful tool. So I'll go on to the next slide. So this is a short overview of LGC's diverse selection of probe chemistries. Right, so Biosearch is best known for its black hole quencher technology. Maybe some of you are familiar if any of you have ordered any oligos from us before. So it's black hole quencher technology, so it's BHQ. You might have heard of it. It was first developed by Biosearch as the first and still the gold standard quencher on the market. So majority of major molecular diagnostic assay manufacturers actually use BHQ as their core chemistry for diagnostic assays. And of course, joining the family of probes recently in 2022 was as well as our focus here today will be the minor groove binding probes, or MGBs for short. Right, so we have over 40 years of leading excellence in oligonucleotide synthesis, and we now offer license-free MGB probes that are of high quality, they are cost competitive for any application, and they are also manufactured under both ISO 9001 or ISO 13485. Right, so let's take a deeper dive into MGBs. So to understand MGBs, first we need to talk a little bit about what makes it so special. So duplex stabilizing chemistries, we utilize this in a few of our probes, including MGBs. So duplex stabilizing chemistries are a group of chemical modifications that can be introduced into DNA probes and primers to increase their binding specificity and stability. These modifications are particularly useful in applications such as PCR and genotyping, where the accuracy and efficiency of the reaction is very critical. So by enhancing the duplex stability of DNA probes and primers, these chemistries can improve the sensitivity, specificity, and the robustness of assays, making them a valuable tool. So here you can see we actually utilize some these duplex stabilizing chemistries in some of our probes, including the LNA, the log nucleic acid, our BHQ plus, and also of course our MGB. And they all serve a similar purpose. They are there to increase the sensitivity and specificity by modifying the oligonucleotides to increase the melting point. So of course there are other means of increasing the melting point. So one of it is using longer oligos, but that can increase or lead to non-specific binding and poor resolution. So how is duplex stabilizing chemistry useful for our probes? So it allows for shorter probe design and better SNP discrimination. So increased stability and specificity during hybridizations. They also enhance ability with difficult regions, including AT-rich regions. They also improve sensitivity because when your oligos are shorter, you actually have the dye and quencher closer together. So this gives higher quenching efficiency and also a greater signal to noise ratio. But of course, this duplex stabilizing chemistry, while similar in function, they all serve to improve the TM. They differ in how it's achieved. So these differences can be used to decide which chemistry is best for your particular application. Okay, so let's look at MGB now. Okay, so MGB probes, they are dual labeled 5' hydrolysis probes consisting of a 5 fluorescent reporter dye and also a 3' duct quencher or EDQ conjugated to an MGB moiety. So this is what gives the MGB. MGB moiety binds non-covalently to the minor groove and stabilizes the target probe duplex, effectively increasing the TM of the duplex. So this increased TM allows probes to be shorter, which increases sequence specificity. Of course, a shorter probe also has a greater quenching efficiency, as I mentioned, because the dye is actually closer to the quencher. And the short MGB probe also leads to low background and high signal to noise ratio. So MGBs are very good for single base mismatches because they have a greater destabilizing effect on than other probe types, particularly when the mismatches are within the minor groove binding region. And this actually greatly enhances the change in melting temperature for a mismatch, and it improves SNPs discrimination. Okay, so our new MGB probes, we have actually performed many comparison studies to competitors in the market, and we have found that our Biosearch Technologies MGB probes actually demonstrate equivalent performance to industry standard MGB probes. Okay, how is this useful? Is because if for instance, if you're actually using any MGB probes right now and you feel like you feel like making a switch because of any reasons, you can be sure that once it's a one-for-one swap. Once you swap to our MGB probes, you can actually carry on with your experiments, and because it's exactly the same performance and the same technology. So be sure to not be disruptive to your work in the lab. And you can see over down there on the graphs there, the CQ values for both our MGB probes and competitor X have equivalent performance with the PCR efficiency and R-square values passing PCR criteria for all dyes. So on the screen here, you can actually see 4 dyes, but we recently have already added 2 more for a total of 6 dyes, which maybe I'll show a bit later. Okay, so what are MGBs and how can they help to solve your complex plant genotyping issues? Okay, so there are many difficult plant samples, especially plants. Also plants like sugarcane and strawberries, they have 8 sets of chromosomes. So this is a polyploid, making genotyping a complex and time-consuming process. Potatoes as well, they have SNPs as frequently as every 29 base pairs. So all these SNPs all being very close together, these flanking SNPs can actually give rise to false positives if the probe doesn't discriminate enough or it's too long. Okay, these SNPs of interest are often located in the center of AT reach or highly repetitive regions, which can make it difficult to design probes that are both specific and sensitive. So this is where MGBs can help. And I actually have a link for the blog here on our blog on discussing all these complex issues. I think maybe after the presentation, if you're interested, you can actually contact Phil Korea. I will pass them the link and they can distribute it for your own further reading. So how does MGB help? So some of the common ways people use to tackle these issues is by increasing the specificity, is to make them as long as possible, because making it longer actually increase the specificity. But that does not solve the problem because longer probes will increase sequence mismatches and is an absolute no for SNP detection. Of course, inversely, shortening probes will also hinder hybridization and destabilize probe binding. So here, addition of an MGB moiety to your probe increases both its melting temperature and specificity, and at the same time allows you to have a significantly shorter length probe. This improved quenching efficiency means even lower background fluorescence and a better signal to noise ratio. It's 1,000 times more sensitive than conventional qPCR, making it a valuable tool for protecting crops and genotyping your crops and ensuring food security. Okay, so another thing I want to touch on is the purity and integrity of the extracted DNA. So these are some of the problems that researchers always face. The purity and integrity of your extracted DNA is another factor that can heavily influence the caliber of your genotyping data. So breeders and researchers always encounter these issues with crude DNA samples. So, however, purifying DNA extracts takes a lot of time and a lot of money, and it might not be feasible when working with high number of samples. It's just too expensive and too time consuming. Crude DNA samples also contains a lot of enzyme inhibiting factors, which will inhibit your PCR and affect your genotyping data. So LGC have actually tested MGB probes with our BHQ probe master mix. This combination actually gives very highly specific and sensitive even with crude DNA extracts. It even works with very difficult plants that researchers always encounter, like maize and soy, without any purification needed. And we have even tested it in volumes as low as 1 microliter. It is robust and cost effective, and it's easy to scale up. And also, of course, we have a poster link right here that links to the poster that shows this testing. If you're interested for further reading, you can approach Korea and we can distribute this link for further reading. It's also on our website. If you manage to find it, you just need to type in a few keywords: crude DNA MGB probes. Okay, so these are some of the product specifications for our MGB probes. So usually we recommend a probe length of 8 to 30 bases, and the dyes available are listed here. We have 6 dyes available now. And of course, our quencher will be the EDQ quencher, which is equivalent to MGB. I think maybe other companies will use a different name, but ours is called EDQ. The yield we have is 10, 20, or 60 nanomoles delivered. So this is not actually the scale, it's the exact nanomoles that will be delivered to your lab. So everything is very precise, and you can be sure that this is the amount that you're getting, and not the scale used to synthesize your oligo. So purification, we always recommend reverse phase HPLC, but of course, if you want higher purification, you can always speak to us. Delivery format will be in dry or in solution, depending on your needs. Quality control will be mass spec or ultra HPLC, according to what your quality standards are, because we have ISO 9001 for RUO and also ISO 13485 for your GMP needs. Shelf life will be 12 months from the day of manufacturing, and the shipping conditions are in the ambient temperature. Okay, so here are some of the comparisons with the probes that we have. So because every probe, they actually have different strengths. So here is a comparison chart here. So MGBs are useful because they are sequence agnostic. That means that you don't really need to care what sequence you are designing your probe for. You don't need to worry about whether MGB works for that sequence. So in that sense, the design is very simple. You just need to design your probe, and you just need to add an EDQ quencher, and it's an MGB probe. So it's very straightforward. You don't need to have any technical knowledge in designing probes. And it's also ideal for SNPs and difficult gene expression targets because of the MGB moiety. It actually increases the melting temperature if the melting temperature if the mismatch actually lies in the MGB region. But of course, there are also downsides to MGBs. One of the downsides here is that you cannot fine-tune the TM here. That's why you see the box is grayed out, because MGB just sticks to the helix indiscriminately. So you cannot actually fine-tune the TM like what you would do with RNA, because RNA you can actually choose which bases you want to input the RNA and how many you put and how many how many LNA you put in the bases actually affects the TM. So you can actually fine tune the TM that way, but for MGB, you cannot fine tune the TM. And also, MGB chemistry is not suited for anti-sense approaches. And also, MGB modifications are linked to the quencher, so it's only restricted to hydrolysis probe offerings only. But I can see here that MGBs are very useful because they are easy to design, they increase stability, and they help with SNP genotyping by increasing the sensitivity and also gene expression in AT-rich regions. Okay, so actually that's about all I have to say for MGB. So from here, I will try and explain to you why LGC Biosearch Technologies are a good choice. We talk a little bit of our history and our capabilities and how we are well positioned to support the customer's needs. Right. So because we have been in the oligo business since the 1980s, so that's about more than 40 years of experience in making oligos. On the left here, you can see Ron Cook, which is the founder for Biosearch. He's actually in the picture with the inventor of PCR. His name is Kerry Mullis. Here in the picture, he's actually the person that invented the PCR. So we go a long way back. And in the middle here, you can see the record of the first oligo sold commercially in 1980s, and it's actually sold for 9,000 USD. So fun fact, the same oligo today will only cost about 25 USD. Okay, so on the right, you can see the first commercial DNA synthesizer to market. It's used by Kerry Mullis. Of course, he's a good friend to Biosearch founder Ron Cook. So they use this to synthesize the first oligo. So in 2015, Biosearch was acquired by the LGC group. So oligo synthesizing is actually a core strategy of LGC across all our market segments. So, and since then, we've continued to acquire many oligo companies, and all these oligo companies have their own expertise and portfolio, such as CPG, manufacturing, dye production, and oligo synthesizers. So much so that even competitors, they also buy oligo synthesis starting materials from us. So LGC now has the largest oligo production portfolio and capability in the industry. Okay, so supporting MDX assay developments, our mission is we will be the agile go-to partner for mission-critical genomic components, supporting our customers in solving the challenges of our time. So we pride ourselves in ensuring that we partner with customers to help and be involved in the assay development to ensure that we can consistently produce whatever oligos that you pick into manufacturing scale. So of course, making an oligo once for R&D and for RUO is relatively easy, right? But our specialty here is ensuring that the oligo you design and you select can be scaled up and to be manufactured reproducibly. We ensure that you receive the same quality and consistency of products every time, from initial validation to large-scale production. Again, moving from R&D to production, consistency and quality is very important. And we actually did a survey with customers, and this is actually ranked as top priority in our customers' feedback. And we have teams in place for each step to help you navigate and optimize where needed in every stage of your development process. Okay, so talking about quality, we have historic strength has been Biosearch's historic strength has been quality and reproducibility of our product. We became a market leader in IVD grade oligos through quality and word of mouth. We have one of the best reputations in the market and a lot of loyal repeat customers who come back for new assays and product lines from Biosearch. As you can see, we have quality systems ranging from ISO 9001 for RUO products. We have the ISO 13485 for your GMP needs. We also have up to ICH-Q7, which is a quality grade for therapeutic oligo to be injected into humans. So they actually have the most rigorous quality expectations. Of course, we also have multiple sites with these ISO certifications. We have world-class QMS monitoring and infrastructure. We also have US FDA registration for manufacturing and labeling, and also GMPA compliant IVD components. Okay, ensuring consistent high quality. Biosearch focuses on a lot of MDX production. So we go through extensive lengths to ensure that there's no cross-contamination between production lines and eliminate any template or controls from being manufactured in the factory. So you can be sure whether you're ordering it for your R&D purposes or your commercial purposes. You can be sure, rest assured that it will not be contaminated because we go through a lot to try and mitigate all these factors. So during COVID, this actually really stood us apart from the competition, as throughout the whole COVID period, we had zero contamination issues. Right. We also have things like long-mer screening. So if you are looking to synthesize long oligos, we actually will screen them first before synthesizing, because it might pose some contamination risk to our factory. So you can be sure that once you submit your sequences, they are safe from contamination. Okay, so we have oligos for all phases of development. One of them is, of course, ISO 9001 oligos for your RUO, for high quality, reliable, cost-effective research, routine research. We also have ISO 13485 oligos. These are ready for IVD, molecular diagnostics, and commercial applications. So to highlight here, the quality between these two are actually the same. They are not. It's not that one is not as good as the other. It's just that ISO 13485 is using the GMP production method for commercial use. So it just has a bit higher consistency and also batch record traceability. Right. So we generally work with companies using RUO oligos for R&D, and when they go to commercial, we have the option to use ISO 13485 for using GMP production methods, and this is suitable for companies producing FDA-approved or FDA-approved kits that gives additional supporting paperwork and documentation that is required when putting all these kits into commercial use. Okay, and of course, our resilient supply chain, right? So LGC's nucleic acid chemistry portfolio has grown extensively within the last 8 years, since 2015. And this was made possible by the successive acquisition of 5 companies here who are considered experts in their respective core activities and they are dedicated to oligosynthesis. So of course, as mentioned just now, it started with the acquisition of Biosearch in 2015. Biosearch has a long history of providing modified solid supports and phosphoramidites to molecular diagnostic companies, and also the inventor of a famous BHQ, the gold standard of fluorescence quenching, and one of the most referenced quenchers in peer-reviewed journals. And in 2016, LGC acquired Prime Synthesis. Prime Synthesis is a market leader in developing controlled pore glass, also known as CPG. CPG supports for oligonucleotide synthesis. And a year later, in 2017, Link joined LGC, and we grew our NAC portfolio with a wide range of specialized products, including modified solid supports and phosphoramidites, and also conjugation reagents and spacer modifications. And in 2018, we further bolstered our portfolio by acquiring Bioautomation, who is the manufacturer of our renowned mermaid oligosynthesizers. And also in 2018, lastly, we acquired Berry and Associates, a company with extensive experience in manufacturing modified phosphoramidites and nucleosides. All these recent acquisitions have led to the creation of a comprehensive and fully supported NSA product portfolio. So we are also very proud to be able to offer our customers a single point of contact, no matter what you need, whether if you need to just buy oligos for research, for commercial use, or you want to buy oligosynthesizers for your lab so you can create your own oligosynthesizers. We have everything you need, even raw materials, to meet all your oligosynthesis needs. Right, so having all this under our belt, we have control over supply chain and quality. So this is a vertically integrated business model where we have everything from CPGs to manufacturing. So this allows us to keep a tighter control of the quality and supply chain, ensuring we have raw materials on hand and can provide lower cost structure for bulk product. So you won't have to worry about, like example, in COVID, you have supply chain issues. You won't have to worry too much because we control supply chain on our side. And of course, we have redundancies involved. So we have global oligo manufacturing presence. So this will ensure supply chain continuity. So we have all these production sites globally for both oligos and raw critical materials. We have especially key oligo production sites in California, Petaluma, and also Listrup, Denmark. These two sites are actually expanding very quickly, and they have a huge capacity and provide complete second sourcing for both IOO and GMP oligos, protecting customers who rely on these items as a critical component. They are also very high quality, cost competitive, and ISO 9001 and ISO 13485 certified. Okay, so all these multi-site manufacturing operations, they provide redundancy, they mitigate risk in case of any supply chain issues, and also any surge in capacity, like example in the COVID period. Yeah. So we have fully equipped manufacturing services, as you can see from the pictures here. We have from custom oligos to GMP. We have contract manufacturing that we provide OEM services as well. Custom liquid handling and formulation. And also fill and finish for IVD keeping and formulation, and even custom labeling and custom modifications. Okay, so next up, we have production capabilities. We can produce from small to very large scale and can work with you every step of the way to ensure complete consistency of oligo quality and the specifications as they scale up in your research and business. So large synthesis scale from all the way from 500 nanomole up to millimole. We also work with any type of oligo design and modification. We have more than 250 modifications available. We have even rare specialty bases, RNA and DNA-RNA hybrids. So we can support any kinds of chemistry and dyes available on the market. We also optimize purifications for your requirements depending on assay and oligo types. So we have comprehensive purification methods according to what you need, and we also have dedicated purification columns available during manufacturing. Yep, so that's all I have for MGBs and our oligo production capabilities. Now maybe I can open the floor up for any questions that you might have. And of course, if you have any questions after this webinar, feel free to shoot me an email. My email is here on the screen. Also, please, of course, include my friends here at Korea, so they can help assist you in case there are any issues that they can help you with in the inquiry.